Now, the mathematical steps we've taken so far have only given us the empirical or simplest formula. The actual ratio of the atoms in the compound is called the molecular formula. So that's our next step. If we know the simplest formula, maybe we have one carbon and one hydrogen. That's a 1-to-1 ratio. That's the simplest ratio. What is the actual ratio? It could be 8 carbons for 8 hydrogens. It could be 14 carbons and 14 hydrogens. It could be 1 carbon and 1 hydrogen. We don't know at this point, so we need more information. And the extra information we need is the molar mass of the compound. Now, if we knew the formula, we could just look it up on the periodic table, but we don't know what the formula is. We get this molar mass from an experiment. And that experiment is beyond what we're going to talk about in this class. So we're just going to take the answer from the molar mass. We're going to use that experimental result. We're not going to actually talk about this experiment that gives that to us. Once we have that molar mass, we can calculate what's called the scaling factor. Scaling factor is just the ratio or the division of the molar mass of the molecular formula, which is the true ratio of the atoms together in the compound. We're going to divide that by the molar mass of the simplest or empirical formula, which we get from the mathematical analysis that we've been working on. So for example, let's say that we go back to this empirical formula, 1 carbon for every 1 hydrogen, and then the results from this experiment tell us that our actual compound has a molar mass of 78.12 grams per mole. So I'm going to plug that into the numerator of this scaling factor, and I'm going to divide that by the molar mass of the simplest formula. Well, 1 carbon and 1 hydrogen, add those up on the periodic table, gives me a molar mass of 13.02 grams per mole. So when I divide those, notice the units cancel. This will almost always be a whole number, and if it's not a whole number, it will be very close to a whole number. This is not one of the times where you have to worry about multiplying by 2 or 3 or 4 to make it a whole number. Within rounding, this is going to give us an answer of 6. So this 6 scaling factor we're going to use, and we're going to change the simplest formula, the empirical formula, C1H1, and whatever the scaling factor is, we multiply each of these subscripts by that scaling factor to give us the true molecular formula. So in this case it's 6 carbons for 6 hydrogens. That is our molecular formula.